right, let's go and get started by reviewing some things we've talked about over the last few lessons. We recently talked about, we're not going to talk so much today, but I did want to review some terms about graphing. And we said when we graph, we get graph paper. And you can't do anything on graph paper as far as graphing until you draw a couple of number lines, which we call... I was pointing to Ethan.
Yeah, axes.
Axes, yeah, good, Ethan, good. And so Ethan, what's the up and down axis, the vertical axis called?
X and Y.
Which one's this one?
Yeah, X.
Oh, Ethan.
The Y.
The y-axis is the vertical axis. The horizontal axis, Ethan, is the
X.
The x-axis. And, of course, the axes go to the right and up to infinity, respectively. Of course, to the left and down to Jamie? Negative infinity. We only label the x and y on the positive infinity ends of the axes. They intersect, Jamie, at a point called the origin. Every point on this, so what we call the Cartesian plane, once we've drawn these things, every point on the Cartesian plane has a specific x value called the, and a y value called the, but we put them together to get that point's coordinates. Because, for instance, you say, I'm thinking of a point with an abscissa of 3. Well, as we showed, there's an infinite number of points with an abscissa of 3. They make a vertical line around right where there's an abscissa of 3. Or a lot of points can have the same ordinate, but only one point can have a specific set of coordinates. We said those two perpendicular axes form 4 sections, or on the Cartesian plane. Where's the first quadrant?
Top left, top right.
Top right. Again, we think top left is how we would read, but it's actually top right, then top left for 2, bottom left, and then bottom right for 4 as we work our way around. We then talked about trigonometric ratios. In right triangles, we said we can make ratios comparing 2 sides to each other. And we started with 3 main trig ratios.
Sine, cosine, and tangent.
Sine, cosine, and tangent. How do we remember how those different ratios are put together, Chris?
SOHCAHTOA!
Very good. They actually said SOHCAHTOA. And what does SOHCAHTOA mean, Chris? I like the that's great.
Opposite hypotenuse, adjacent hypotenuse, and opposite adjacent.
For what?
SOA is opposite hypotenuse.
SOA? So stands for what 3 things?
Side
is
opposite to
over
the hypotenuse.
There we go. And then the ka
is adjacent over hypotenuse.
What? Ka.
Card.
Quite
Cosine is adjacent over hypotenuse.
The cosine's adjacent over hypotenuse. Toa.
Tangent is opposite over adjacent.
Good. So SOHCAHTOA, sine, cosine, tangent. But we added 3 new trigonometric ratios that we really don't have to do any extra math for, really, because all they are
the reciprocal?
Reciprocals, the flip, if you will, the reciprocals of the original 3. And so we said that while sine is opposite over hypotenuse, its reciprocal...
The h is over out.
Right, but which trigonometric function or trig ratio is the reciprocal of sine?
Is it cosecant?
Cosecant, abbreviated CSC. Of course, we know that cosine's adjacent over hypotenuse. What's the reciprocal of the cosine?
H over A.
Right, but what do we call, what's the name for the reciprocal of the cosine?
Secant.
The secant, good, SEC. And let's get started here in just a few more weeks. Hang in there, boys and lady. Do you like college football? Okay, so you don't have to hang in there. They have to hang in there. We'll hang together. All right. Tangent, of course, opposite over adjacent. What's the reciprocal of the tangent?
What is sort of?
See?
Cotangent.
All right, so adjacent over opposite. So there's our different trig ratios: sine, cosine, tangent, cotangent, secant, cosecant. Notice you'll never put 2 cos together. Okay, so there's always a co with another thing, but tangent, cotangent are named with each other. Cosine, plain old secant, plain old sine, cosecant go together. And you were practicing with these trig ratios for homework. You did page 12, numbers 2 and 4, and page 13, number 10, which used the calculator. Number 12, or 2 and 4 did not need a calculator. Have that homework out, books open to page number 12. Let's see how you did.
Oh, number 10.
There's 2, there's 4, and 10 10, you didn't use the memory.
Yeah, because I didn't have.
Ah.
I had my phone, but the calculator.
Your phone calculator is not good enough, is
I
it?
started time is I had half of the stuff I needed. Not the memory.
Alright, yeah, that's a bummer.
Yeah, it is. Which means I got to pretend wrong.
I make sure we label things properly, because Chris, that's how you're going to remember the names of the different functions. As you write those abbreviations over and over again, it'll help your memory. So don't shortchange yourself and hurt yourself in the long run. Let's take a look at number 2, and we were given this angle. I don't think I've given you this Greek letter before. Anyone happen to know what this B-looking thing is? Beta, very good. So beta, spelled B-E-T-A. If you're familiar with technology, a beta version of something means it's not quite finished yet, but
Closer than
geeks and nuts get to play around with it a little bit. Like the beta version of Windows 11, right, has come out now. I'm a little weary of Windows 11 because all the odd. Well, no, Windows 7 was good, but that was an odd number. 8, ugh, trash. They skipped 9 completely because they knew that would be bad luck. They went to 10, which is meh. I still say Windows 7 was the
I
best.
think Windows XP is the worst. Or Vista was pretty good.
Vista was rough. Anyway, let's get back to the task at hand. Geeks and nerds, okay, we've shown our colors. All right. But anyway, beta. And we were given the opposite of beta is 5, the adjacent leg is 12, and the hypotenuse 13. And so pretty straightforward, finding the sine of beta, the cosine of beta, the tangent of beta. Remember I said on quizzes and tests, we're just going to continue straight down. Tangent, then cotangent, secant, and then cosecant. So the co comes after the main name. Sine, cosine, tangent, cotangent, secant, cosecant. But their pairings are like this for their reciprocals. So the sine of beta, class, we need to remember sine is what over what? Opposite over hypotenuse should be 5 to 13, which means come all the way down to cosecant, 13 to 5. Cosine, class, is adjacent over hypotenuse, which should be 12 to 13. Again, come down to the secant, 13 to 12. And then tangents, what over what? Opposite over adjacent, which of course is 5 to 12, which means cotangent, flip it, 12 to 5. Here's the downside. You get it backwards on sine, cosine, tangent, or get something mixed up, now you're doomed to missing a second answer as well. So you better know SOHCAHTOA really well so you don't botch 2 answers at the same time.
Think about it. Think about it.
All right, let's take a look at the next one. And here, given alpha, which we've seen before, and given the opposite of 9, adjacent of 12, hypotenuse of 15, and I'm lazy, so we're going to do this right here, and we're going to find the sine of alpha, cosine of alpha, tangent of alpha, cotangent of alpha.
It's like a fish.
It kind of looks like a cross between a fish, like, like the Christian fish symbol, if you will. It doesn't come to a point, though.
Sweet.
And it kind of, like almost an infinity, but also an A. So if you cross the two, you come up with something like that. But anyway, for the sine of alpha, sine's what over what, class?
Opposite over hypotenuse.
Opposite over hypotenuse, which would be 9 to 15, but we'll reduce it 3 to 5. Once we've got sine, come get cosecant. It's reciprocal. Cosine's what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. SOHCAHTOA. Think Spanish, right, where the A makes the ah sound. SOHCAHTOA. Adjacent over hypotenuse, which will be 12 to 15, reduces 4 to 5. Once you get the cosine, get its reciprocal. Secant. 5 to 4. Tangent, TOA, what over what? Opposite over adjacent, which would be 9 to 12, reduces to 3 to 4. Get the reciprocal. Cotangent, 4 to 3. All right, questions on those? Yes, sir.
I have a question. So if you were to have a triangle with all even numbers, before you even started doing it, say it was 12, 8, 16, could you reduce it before you even started?
Absolutely. If you look at the sides, you're like, wait, I can see that there's already going to be a 3. Instead of thinking of reducing every time, if you want to knock it out right from the get-go, that's actually what I tend to do mentally on a lot of mine as well.
That's what I do.
So that's legitimately big brain. I know we pick on you sometimes, but that is actually a really good idea, is knocking it out early, reducing things down. We had one the other day that was, I think, a 10, 24, 26. Well, that reduces down to 5, 12, 13. By the way, 3, 4, 5, 2 legs and hypotenuse is called a Pythagorean triplet. I actually mentioned this to you last year in geometry class. Okay? But a Pythagorean triplet is 3 sets of integer lengths for the 3 sides. So 5, 12, 13 is another Pythagorean triplet. And once you start recognizing triplets, it saves you time. For instance, if I gave you a side of 3 and a side of 4, instead of using the Pythagorean Theorem, you're like, oh, I've already memorized this 3, 4, 5. Or if you knew 5, 12, 13, like, oh, one side's 13, one side's 5, oh, the other leg must be 12. If you just already had these two memorized, these are the most common. Now, I can do variations, right? Like 9, 12, 15, 6, 8, 10, 15, 20, 25, right? Just multiply. So I can make a whole bunch of triangles based on these two triplets. I do use other triplets as well. We sometimes use the 8, 15, 17 triplet, the 20, 21, 29 triplet, 12, 35, 37 triplet. And so there will be times where if you didn't know about these, you'd be like, how does he make that up and do that in his head so quick? I don't. I memorize triplets. And then I change the numbers. So I'll do 16, 30, 34, for instance, and maybe double all the numbers in a triplet. And then I can make up so many different combinations. So that's math teacher hack. But if students understand what math teacher's brain is doing, students can cheat the system. So I've got two people who are furiously scrambling it down, and two people are like, we've already memorized them. All right. All right. Well, once they're done furiously scrambling down triplets, by the way, look at number 6 at the top of page 13. Notice the triplet?
Yep.
Yep. All right. However, what you see on number 10 from your homework, not a triplet. There is no 5, 6 something triplet. It doesn't work that way. So,
5, 6, 9.
Nope. Nope, it's just not a triplet. We have to use a calculator for this one. Let's take a look at number 10 from the homework calculators. At the ready, Ethan. And we had the angle alpha down here. We had an adjacent side of 5.0. Notice they left the units off. Why bother? They had a 6.0. Again, the units would cancel anyway. And then we needed to start by finding the hypotenuse. You can't find the sine without the hypotenuse. And of course, to find the hypotenuse, class, we use Pythagorean Theorem. Use Pythagorean Theorem unless there happens to be a Pythagorean triplet readily available. And there wasn't, so we do it. And so we get 6 squared plus 5 squared equals, take the square root. We get the square root of 61, which will round off to 2 sig figs, 7.8. However, we don't use 7.8 in our calculations because this is a rounded value. We rounded to 2 sig figs to match these, but we have to use the exact number. How do we use the exact number, Jamie?
Using the memory on the calculator.
Put in the memory of the calculator. So we'll store in memory 1 or 2 or 3, whichever one you want to use. And so we'll put this in the memory. I like to notate the memories used, just so I know, yes, I did put that in the memory. And then when we find, I should have erased them, the sine of alpha, the cosine of alpha, the tangent of alpha, the cotangent of alpha, the secant of alpha, and the cosecant of alpha. It's got to be each way. We will use this number instead of the memory value instead of the 7.8. So, sine of alpha, class, whatever what? Opposite over hypotenuse. So for alpha, the opposite is over the hypotenuse, which is in the memory. So we do 6 divided by memory 1, 6 divided by recall 1, remember. And what do we get for our sine of alpha, Ethan?
0.768.
0.76822, blah, blah, blah. But remember, we're always going to round to how many decimal places? 3 decimal places. Now, for sides, we use sig figs, but for trig ratios, we always do 3 decimal places. So, how do we tell the calculator to do that? Second function, fix 3. And now I don't have to do the rounding. By the way, once you have the sine, you can easily get the reciprocal.
0.7, no.
What do we name? What's the name for the reciprocal of the sine, class? Cosecant. So how do I get the reciprocal on the calculator?
1 divided by 6.
Nope.
1.
The reciprocal button. You could do recall 1 divided by 6, or you could just hit reciprocal, and it gives you 1.302.
Which one is the reciprocal button?
So with the 1 over x button right here, so you go 0, 1, 4, 7, EE, what x? That's the button we're going to use.
Okay.
Now, if you have a different scientific calculator, you may see a button labeled x negative 1, or perhaps the x negative 1 is written over a button. That also would mean reciprocal. Okay, so the negative first power of x is the reciprocal. If you have a different calculator, fortunately, everybody in this class uses the TI-30XA, which is the greatest calculator ever made because it's cheap and does everything we want. Big fan of cheap and doing what we want, right? Can't sacrifice function for cheapness.
My battery.
What?
It's like, it sometimes like goes out like it just did. and they'll come back on.
Ah, so you need a new battery. It's
Yeah.
great because I actually sell and install replacement batteries for only $1.
He does, I've done it before.
He's telling me my whole life.
I actually do have spare battery replacements at home just in case these die. So yeah,
So your mom would break
I would
it
need to take it home. Well, actually, I guess I could bring the screwdriver and batteries here.
I have a question.
Yes.
So if you didn't use the memory function, because I did it on 1.2, you would just be like 0.1 decimal off, because that's what it was on the first one. It was I had 0.69 or I had 0.3.
Yeah, if you use the rounded value, probably by the time you get the 1000th digit, it may or may not be off, and so that's why we want to use the memory.
So it's pretty much exact until you.
It's going to be
get
pretty close. It's going to be
But
pretty
it's still
close.
going to be wrong on the quiz.
Points off, not completely wrong, but points off. Because you showed me you knew that sine was opposite over hypotenuse, for instance, but because you used a rounded value, that's an error. So if it's like a 5-point question, probably take off a point. All right, let's take a look at the cosine. Cosine is what over what, class?
Opposite over
Adjacent
over hypotenuse.
Adjacent over hypotenuse. The adjacent is?
So 5.
5. The hypotenuse is?
Memory.
Memory. And 75 divided by recall 1, and you should have gotten?
0.640.
0.640. Once you get the cosine, go ahead and get the,
Reciprocal.
which is called the secant. By hitting the reciprocal button, we get?
1.562.
I'll say it for you.
It's actually 1.56 because we do 3 digits, right?
No, 3 decimal places.
Oh.
Decimal places. Yeah, good question. Which is why the fix works, by the way, because the fix only does decimal places. It doesn't do sig figs for you, which we're going to talk about in physics tomorrow.
Oh.
All right, let's take a look at the tangent. Tangent's what over what?
Opposite over adjacent.
Opposite over adjacent, which would be
6 over 5.
6 over 5. And of course, you might be able to do that. You had 6/5, 1 1/5, 1.2. But tack on 2 zeros, or you can do it on the calculator. And what's the reciprocal called?
0.833. Oh, it's the cotangent.
Cotangent, which of course would be the reciprocal, which is 5/6, which you might have memorized. 0.83 repeating, or we'll do 0.833, or you can do it on the calculator in junior high.
For what?
They memorized a whole bunch of different, like for instance, 1/5 is 0.2, 5/6 is 0.83 repeating. There are a whole bunch because it makes you work so much faster if you just know a bunch of them. So there's about a dozen or so fraction decimal equivalents they memorized in junior high.
I don't remember.
Interesting.
Well, they should have memorized. All right, questions on this? Let's do another one of these together. On your paper, go ahead and draw a right triangle. Let's label the hypotenuse as being 16.7 inches. And let's label the baseline as being 9.1 inches. And let's mark this base angle like we had last time. Anyone remember what that Greek letter is called?
Is the
Not
theta.
theta.
theta? No, it's not.
Theta's got the horizontal line.
Is it the 0 with the line in it?
It's the equivalent of our F.
Theta.
Phi. Phi. Spelled P-H-I. Okay, it's the F sound. All right, and we first of all want to find the missing leg, and then all 6 trig functions of phi at your seats.
That's not right.
Do you need to rent a calculator for 50 cents today?
No. Not me, my money.
You know me, I'm always ready to assist.
I know, right?
Do we have to take off the fixed function for this?
You don't have to, no.
Why would? I got 196.
Well,
Square root. Oh yeah, you were there. Moppy. Can I write so katoa instead of sin, whatever? Because
well, if you want to write SOHCAHTOA to help you remember what's what, but we actually need to write out the sine of theta equals this, the cosine of theta equals this, because we're writing out our answers. There's 7 answers I'm looking for. But yeah, if you want to write SOHCAHTOA,
can you write all places in test?
yeah. Just don't misspell it.
I
I used to spell so as S-O-A.
That's not how you spell
I
it.
know.
So.
It's S-E-W. Or S-O-W.
What?
If you're talking about the word, if you're talking about the mnemonic device, it's S-O-H.
So confused.
Did you find the missing leg to be approximately, not exactly, approximately 14 inches? Notice we will round off to 2 sig figs for this answer. This is not a trig ratio, but the ratios we're going to do the 3 decimal places. Don't use 14 though, put it in the memory, use the exact value. By the way, if you just store in memory 1, it will overwrite the old one. So you don't actually have to clear memory 1. You just store in memory 1 and it ditches out the old one and puts in the new. So kind of like the clipboard on a computer when you copy and paste. Once you copy, it overwrites whatever was there before. Same kind of idea here.
I haven't heard the word clipboard used for a computer in like 10 years. They don't call it that anymore, it's called copying and pasting.
No, it's copied to the clipboard. It still calls it that on the computer itself. In fact, you can view clipboard if you want to see what's on the clipboard. That's what it's called. They still use that terminology even in 2021 Office 365.
Boomer.
Windows 10.
My calculator, but it would work.
I could rent you one in the meantime.
You should do a deal, like if he buys the battery from you, you get to give him a calculator for free for the day.
I need to charge a higher battery fee then, because I was only covering the cost of the battery plus labor, so I need to also include calculator rental. Well, yeah, I have to remove the screws and take the old battery out, put the new battery in.
That's hard work.
I tell you, hey, time is money. My work is worth something.
That's what I tell my boss, but he doesn't listen.
He just says you're fired.
he just says get back on the line.
Yeah.
He obviously doesn't value you as highly as you value yourself.
No, I'm a narcissist. I didn't get that for the CSC. I got 0.650.
You did something wrong then.
Hold up, so it'd be.
No, don't type in 0.838. You have to use the memory value to get it, because that's not exactly 0.838. That's rounded 0.838. So when you take the reciprocal, it may not come to exactly 1.193. Might be 1.192 or 1.194. You don't want to lose points.
Yeah, we did.
All right.
0.838.
You think it'd go?
I just mixed a CSC up with the cot.
Cosecant with cotangent?
Yeah, the cot.
Okay.
All right. Quentin, good to go? Double checking answers. Jamie, good to go? Chris, other than mixing up cotangent, cosecant? Careful. Okay. Remember.
Oh wait, for tangent I got.
These go together. These go together. Those go together.
For the tangent I got 1.538.
All right. Do page 13, number 11. Yeah, you can write it right there in the book. Is that, by the way, notice we've got one side 10, the other side's 5, which is exactly double, right? Is that a 30, 60, 90?
Yeah, no.
If it were the hypotenuse that were double, yes. As an easy trap to fall into, so be careful. Hypotenuse is double, it's a 30, 60, 90. If it's a leg that's double, it's not.
Yes, what?
Again, the missing side, which in this case is the hypotenuse, round to sig figs. And if necessary, use units. If they give you units, you got to use units. Then, of course, the ratios themselves, 3 decimal places, and of course, no units. Units always cancel.
I just tried to recall and I pressed store instead of recall. So it restored the wrong thing.
Well. So missing side. Then of course we'd want to round off to sig figs. How many sig figs are we allowed? 2. 2, so we'll round off to
just 11.
And what unit?
The beta.
No, what unit? 11 what? There we go. Alright, so again, that would be a couple points off because sig figs, units, okay? And then of course we want to say sine beta equals. Let's see what we got for our answers. Good, yes. Get the third decimal place. Good, good, and good. Excellent. Of course, again, just notation. Go on to 13 and 15. Take time to write those answers out properly so that way you get that practice.
What was the reciprocal limit again?
The 1 over x. Just like the reciprocal of 2 is 1/2, the reciprocal of 10 is 1/10, so 1x is the reciprocal of x. Finished? Under the camera level. Okay, round it off to sig figs though. What's the length of the hypotenuse? You don't actually have to write, just, you've got most of it there, we just need to round it off. So, but round it to sig figs, because it's a length, we would have how many? Do we get 3 or do we get 2? 2, so careful there, that would, 8 would bump that up to 2 anyway, but we would get
12.
How does the 1 bump this up?
No.
No, so just 11 centimeters, right? All right, let me go and give you the answers here to these, and then you can all go on to 13 and 15. Number 11, the hypotenuse should round to 11 centimeters. 11.18, blah, 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 should have gone in the memory, but rounded 11 centimeters. The sine of beta, 0.894. The cosine of beta, 0.447. The tangent of beta, 2.000. The cotangent of beta, 0.500. The secant of beta, 2.236. And the cosecant of beta, 1.118. All right, we good to go on those?
14 and 15.
All right, Quentin, question? All right, go on to 13 and 15. 13 and 15 on the next page. and 15. finished? I'll check in just a second. So missing side is, what does that say? 44. Oh, you forgot to take the square root. Okay, so that means these are all wrong. Let's take the next one. This one, notice 3 sig figs, 3 sig figs. We actually want a third sig fig here. But it appears that your answers here are all correct, at least. We just put a little equals in between the sign of alpha equals the other. And so, what was it?
14.0.
If you round it off to the third significant digit, it'd be 14 point. There we go. All right, good. Yeah, so you're going to have to go back and redo 13. And the good news was you were done quickly, so you've got time while they're working. Quentin is finished. Let's go. Yeah. Throw stuff on the floor.
13, 15?
Yeah, 13 and 15, yes. I know it seems a little odd, but we'll do it anyway. Alright, so missing side. Make sure we use the unit they use for our answer. And then here, they gave us 3, 4, 3. So our answer is going to have 3 sig figs. Not 3 decimals, but 3 sig figs. So what would that round to?
14.3.
There we go. So I'm going to update that. And as far as your ratios, they are perfect here and here. Great job. All right, Chris redid it. Good, except here 2 or 3. So we're going to go with only 2. We always go with the smaller number, so what would this round to?
6.6.
There we go. So we're going to cross out the little 3 there. All right, and then updated answers here. And that alpha, you don't like that alpha, do you?
That's alpha? That was an A.
That's an alpha. Yes, yeah, plus or minus. It's okay. I won't dock you for that. Good. Excellent, got them all. So you two gentlemen. Nope, they're about finished anyway. Okay, I won't have you go ahead.
I feel like I'm in summer school again.
What?
I feel like I'm in summer school again.
Well, to an extent, if you get done really early and they've got a little ways to go, I might get you started on the homework, but they're pretty much done. I said that.
Yes.
Yes.
Calculator completely stops working.
That would be tragedy.
Not for you, you get money.
I said then he'd have to rent something.
Or you'd rather than merit.
Well, I don't know.
It's like running out of.
It's not like he didn't have it. He didn't, but he did know it was dying in advance and did not take action.
Well. I don't know about that.
All right, let's go over the answers here very quickly. Number 13, the missing leg should have been 6.6 meters. Once you got that, the sine of alpha is 0.553, cosine alpha 0.833, tangent of alpha 0.663, cotangent of alpha 1.508, secant of alpha 1.200, and the cosecant of alpha 1.809. I've already checked their answers. Ethan and Jamie, how do we do on that one? Perfect.
I got
And
the last one, the cosecant wrong.
what did you have?
I have 1.808.
And you did use your memory value?
I think I did.
Maybe it's bad.
You may have just copied it wrong, or maybe you started to do something and you cleared it, and maybe you retyped something, and that's why it rounded wrong. Let's check 15. Your missing leg, it should have been 14.3 inches. Note 3 sig figs for a change. And then for your sine of alpha, 0.714, cosine of alpha, 0.700, tangent of alpha, 1.020, cotangent of alpha, 0.980, secant of alpha, 1.429, and the cosecant of alpha, 1.400. Good to go on 15. All right. I want you to consider something for just a moment. Suppose we were given a single trig ratio, no triangle or anything, just told that the sine of, let's go with theta, is 2 to 3. And the question is, what's the cosine of theta? Or for that matter, the tangent, or the cotangent, the secant, or the cosecant. From just a single trig ratio, no triangle or anything, just a single trig ratio, we can actually figure out all the other trig ratios. Thoughts,
I
Chris?
think I know how.
Okay.
Because if you know the sine, then you already know the opposite and the tangent. And you figure out the
Ooh, opposite
opposite
and
and the hypotenuse. And then you figure out the adjacent.
there we go. If you already know one trig ratio, you know two sides of a triangle, how would you find the third side, class? Pythagorean Theorem. Now, we usually think c squared equals a squared plus b squared. You could also think hypotenuse squared equals opposite squared plus adjacent squared, right? HOA, Homeowners Association. Anyway, how many live in a neighborhood with a homeowners association? Okay, you do. My parents did when we moved in high school. Our first house was really small, just an older neighborhood. But the newer subdivisions have rules like you can't park a boat in your driveway. You can't have a TV antenna on top of your house because it looks unsightly. You have to make sure you keep your lawn mowed, or we could fine you. Like if your yard looks bad, we'll pay the city to come do it, and then we'll fine you. You have to pay dues to the homeowners association. But sometimes it comes with perks. Like for instance, maybe there's a neighborhood tennis court, which if you pay the homeowners association dues, you can use, or the neighborhood pool, or things like that. Well, anyway, that's how I remember HOA, or just remember hypotenuse squared equals leg squared plus leg squared, and it doesn't matter what order they're in. So point being, at your seats, find the value of the adjacent if the opposite and hypotenuse are 2 and 3, respectively. But I don't want a decimal. I want a radical. So what do we get here? The square root of?
5.
5,
Yeah,
right?
5.
9 minus 4 would equal 5. So we'll just get the square root of 5, an exact value. 3 squared is 9, 2 squared is 4, plus a squared. When you move it over as a negative, you get 5 is a squared, so a is the square root of 5. We don't need the positive negative because you have a negative length on the triangle. And once we know that, we can find the cosine. Cosine's what over what, class? Adjacent over hypotenuse, so it's going to be square root of 5 over 3. For that matter, then, if we know the cosine, we can also get the
CFC.
secant, which is what?
Oh, yeah, I forgot it, yeah. Okay, so
3 over square root of, oh, we can't leave that. What do we have to do now? Yeah, multiply top divided by square root of 5 to get 3 times the square root of 5 all over 5. Square root of 25, which is 5. By the way, since we were given the sign, we can also easily get the cosecant, which is 3 halves, and 3 over 2. Tangents, what over what?
Adjacent over.
TOA, opposite over adjacent. Class, what's tangent? Gotta memorize these. So what's the tangent here? 2 over square root of 5. Let's rationalize it.
2 times square root of 5 over 5. Yeah.
All right, and if we know the tangent, we can also get the... But don't flip the rationalized version. Flip the original. Square root of 5 over 2. That's just going to be a lot easier, right? So when you're flipping something, if you had to rationalize, when you flip it, go back to the irrational to flip. All right, do we see how to do this? All right, page 15, let's take a look at number 21. And they give us in number 21 that the sine of angle A is 3 to 4. Down below, as you copy that down, let's go ahead and list out the others. Cosine alpha, or cosine A, excuse me. I guess technically it could be capital alpha, but we use lowercase for angles. Cosine A, tangent A, cotangent of angle A, secant of angle A, and the cosecant of A. What's the first one we should do, real quick?
Cosecant.
Cosecant. I mean, let's get that knocked out real quick.
4 over 3.
4 to 3. Ooh, maybe this is a 3, 4, 5 Pythagorean triplet. Sine is what over what? Opposite over hypotenuse. So the adjacent, wait, could the adjacent be 5? No, because it can't be bigger than hypotenuse. It's not a 3, 4, 5 triplet this time.
3, 4, 3, 2.
So, using Pythagorean Theorem, you leaving it as a radical, because it's not going to work out evenly, because it's not a triplet, what's the adjacent?
Square root of 7.
Square root of 7. All right, so Jamie, what do we get for the cosine?
The cosine would be adjacent over hypotenuse.
Good.
So, that would be the square root of 7 over 4.
There we go. And therefore, Ethan, what's the secant?
So it's 4 over the square root of 7, but you can't have that, so it's 4 times square root of 7 over 49.
Over the square root of 49, which is 7. There we go. All right. Chris, what's the tangent going to be?
And you were saying, 4 or 3 times square root of 7.
3 over the square root of 7, which becomes
3 times square root of 7 over 7.
all right, and then the cotangent, Quentin.
Square root of 7 over 3.
All right, questions on these?
Also
Get a feel for it? Go right down 20, or right next to it, number 22, and then give us the secant of A is 3. Wait a second. They only give us one side of a triangle now. How could 3?
Whatever 3.
Careful.
3 over 1.
3 over 1. There we go. So if they give you a whole number, it's just over 1. And then now secant, that's not part of SOHCAHTOA, is it, class? But we know that secant is the reciprocal of
Cosine.
plain old secant's reciprocal of cosine. And cosine's whatever what?
One of the
Adjacent over hypotenuse. So therefore secant is hypotenuse over adjacent. Do you see what your brain has to be able to keep up with? All right. So secant, okay, that's the reciprocal of cosine. Cosine, SOHCAHTOA, adjacent over hypotenuse. Hypotenuse over adjacent. So we're missing, class, the opposite. And I need to slide the camera over, it looks like. Okay, let's get all of that in there. There we go. We need to find the opposite. And not so as in SOHCAHTOA. So, not SOA. Okay. Find the opposite for me.
Square root of 3 over 3 would just be 1, right?
square root of 8. Square root of 8.
It'd be the square root of 8, but that's not reduced, is it? Algebra coming back. We could factor 8 into 4 and 2. Take out the square root of the,
4.
which is, so we get 2 times the square root of 2 for the opposite. All right, so we're ready here.
do that.
Let's find the sine of A, the cosine of A, the tangent of A, the cotangent of A. We don't need to find the secant, it's right there. The cosecant of A.
Let's find cosine.
Let's get cosine first. I like that.
1 over 3.
Good job, Ethan. You're not off the hook, though. We gotta get you one more. So let's also have you find the sine of A, Ethan.
Sine is opposite over hypotenuse.
Opposite over hypotenuse, so
So 2 times square root of 2 over 3.
2 times the square root of 2 over 3. Therefore, Chris, what's the cosecant?
3 over 4.
The cosecant.
Yeah, the cosecant. So it would be, because when you flip it, it would be 3 over 2 times square root of 2. You have to get square root of 2 out, so you do 3 times square root of 2 over 4.
There we go. Multiply the top and bottom by square root of 2 to get 3 times the square root of 2 over 2 times the square root of 4, which is 2. So it's 2 times 2, which is 4. Good job there. All right, now we need the tangent. Jamie.
Okay, tangent is opposite over adjacent, so it'd be 2 times the square root of 2 over 1.
Or we could just leave 2 square root of 2, couldn't we? However, when we get the cotangent, Quentin,
So 1 over 4.
well, 1 over 2 square root of 2,
Then you have to multiply. Okay, so 2 times square root of 2 over 4.
just multiply by the square root of 2, so 1 square root of 2, or just square root of 2 over the 4. Does that make sense? We flip the 2 square root of 2, get 1 over square root of 2 square root of 2, multiply just by the square root of 2 to get square root of 2 over.
If you put the 1, if you get the 1, it's not right. If you put the 1, it's not wrong. You're just,
It's not wrong to
you're
put
just
the
very
over.
extra and not very.
Right, I'm just ultra lazy. Yep. Do we see how to work these? Questions on these? All right, let's do one before we go. You'll have a couple more for homework tonight. I want you to do number 25. Number 25. Remember, cotangent is the reciprocal of tangent. SOHCAHTOA, tangent's opposite over adjacent. So cotangent is adjacent over opposite. Did you think that through? What did you get for your hypotenuse? Square root of 5. Any questions on that initial step? Quentin's done. Chris is done. Come on, Ethan. Sweep the girl. There you go. Our long rose among the thorns. Poor Jamie.
Procrastinating.
Ethan's like, I'm too much of a gentleman to be through. I'll let her go first.
3 procrastinators in the female. Oh, what is
Okay, she's done now, Ethan. You can finish.
Excuse me.
Alright, what do we get for the sine of angle A? Jamie?
1 plus square root of 5 over 5.
Good. Initially 1 over the square root of 5, which becomes the square root of 5 over 5.
I got them mixed
While
up.
we're at it, let's go ahead and get the cosecant, which is Quentin.
2. Wait.
That's cotangent. It's 2. What about the cosecant?
Square root of 5.
Square root of 5. Alright. And let's see, the cosine should be what, Chris?
I got them mixed up. I put the 1 as opposite and 2 as adjacent.
Okay. So it should be 2 over the square root of 5, which is 2 times the square root of 5 over 5, which gives us a secant, Ethan, of
5 over 2 times square root of 5.
square root of 5 over 2.
Yeah, that's what I said.
Flip that one. Alright, questions on this? Because you got a couple of these for homework tonight. Alright, homework for this evening is to do page 14, numbers 12 to 18 even. Page 14, numbers 12 to 18 even. And on page 15, 24 and 26. Page 14, 12 to 18 even. And on page 15, 24 and 26. Alright, you are dismissed. Have a wonderful rest of your day.